Since the beginning of time, humanity has looked upward, gazing at the night sky with awe, curiosity, and often a little fear. The darkness above us has been a canvas upon which we paint our deepest stories, our most enduring legends, and our greatest scientific questions. Stars shimmer like lanterns scattered across an infinite ocean. Planets drift silently in their ancient orbits, and the moon hangs as a sentinel keeping watch over the world below. Yet within this wonder, myths are born. Some myths come from misunderstanding, a simple glance at the heavens leading to an assumption that survives for centuries. Others come from cultural storytelling, woven into religion, art, and folklore. And still others arise from movies, television, and popular science fiction, spreading images that become so ingrained in our minds that they feel like facts. Space, in its vastness, invites both truth and misconception. Unlike the Earth beneath our feet, we cannot simply walk into space and test it for ourselves. We rely on telescopes, spacecraft, astronauts, and the imagination of those who describe it. And when imagination outruns science, myths bloom like constellations on a clear night. In this long exploration, we will journey through 5 of the most common myths about space. Ideas so widespread that you have likely heard them yourself, perhaps even believed them at some point. We will not only debunk them, but also expand upon the deeper truths behind them, because the real universe is far more fascinating than the myths we invent. But before we begin unraveling each myth, it is worth taking a moment to breathe, to slow down, and to prepare our minds for the journey. Imagine for a moment lying back beneath a velvet night sky. You feel the cool air of evening wrapping around you. The stars glimmer overhead, ancient light traveling across millions of years to reach your eyes. Somewhere out there, galaxies spin, nebulae glow, and black holes hum silently in the fabric of space-time. And in the stillness, you wonder, what is true, what is story, and what lies between? It is in this quiet space, between knowledge and imagination, that myths about the cosmos are born. Myths persist for several reasons. Space is unfamiliar. It does not behave in ways that feel intuitive. On Earth, we live surrounded by air, pressure, light scattering, and the pull of gravity. In space, many of these conditions change, sometimes dramatically. Without first-hand experience, our minds naturally fill the gaps with assumptions. Language also plays a role. Scientists may use phrases that sound mysterious or misleading when simplified for public understanding, like the dark side of the moon, which conjures images of eternal darkness when it actually means something very different. And of course, popular media adds its brushstrokes. Science fiction movies may exaggerate, distort, or simplify scientific concepts in order to tell a dramatic story. Over time, those dramatizations become part of cultural memory, repeated so often that they begin to feel like truth. Yet, myths are not mistakes to be ashamed of. They are stepping stones toward deeper understanding. Every time a myth is dispelled, it opens the door to something greater, awe at the true nature of reality. The idea that space is completely empty, for example, is replaced by the knowledge that it is filled with invisible particles, dust, radiation, and even mysterious dark matter. The myth of a yellow sun gives way to the dazzling truth of a star emitting a full spectrum of colors, glowing pure white when seen without atmospheric interference. Correcting myths is not about removing wonder. It is about replacing one kind of wonder with another, a wonder rooted in truth, yet no less magical. In this video, we will walk together through 5 myths, unraveling them slowly, carefully, and thoroughly. Along the way, we will travel across interstellar space, visit the moon, stand in the radiant glare of the sun, drift near a black hole, and even imagine what would happen to the fragile human body in the silence of the void. This journey will be long, deliberate, and immersive, designed to allow you not just to learn, but to feel, to sense the scale of the universe, to grasp the science behind the myths, and to leave with a deeper appreciation for the cosmos. So settle in, allow the rhythms of the narration to guide you, let the myths unravel, and the truths emerge like stars breaking through a night sky after clouds have passed. The universe awaits. When we look into the night sky, our eyes tell us a simple story. Between the stars, there is nothing. Blackness stretches across the heavens like an endless curtain, punctuated only by faint points of light. It seems so natural, so obvious that the space between celestial bodies must be empty. After all, when compared to the atmosphere around us, to the soil beneath our feet, or to the water that fills our oceans, the heavens appear silent and bare. But what feels like a straightforward truth is, in fact, one of the greatest misconceptions humanity has ever held. Space is not empty, it is not hollow, nor is it a void devoid of structure. Instead, it is alive with particles, dust, energy, and even mysterious forces that we are only beginning to understand. The universe resists nothingness. Wherever we look, wherever we measure, we find that something is there. This is the story of that something. Long ago, philosophers debated whether a void could exist. To them, emptiness was a puzzle, a question of whether nature could permit nothingness at all. Aristotle declared that nature abhors a vacuum, arguing that a true void could never exist. Centuries later, Democritus envisioned atoms moving endlessly through empty space, imagining the cosmos as a dance of matter in a sea of nothing. As the telescope revealed the stars, scientists assumed the black gaps between them were empty. Without the tools to detect faint light or invisible particles, what else could they believe? To their eyes, space was barren. This belief lingered, echoed in literature, in conversation, and eventually in modern science fiction. Movies really reinforced the idea, ships just sailing through darkness, with no resistance, no trace of matter at all. The myth of emptiness, well, it became almost like a cultural truth. And yet, as technology advanced, and as our instruments grew more sensitive and precise, we started to find that space is actually filled with far more than anyone ever imagined. Between the stars there lies the interstellar medium, a vast ocean of atoms and plasma stretching out across the cosmos. Across the galaxies drifts cosmic dust, tiny grains forged in ancient supernovae. It's fascinating to think about, isn't it? These tiny particles, born from the explosive deaths of stars, float through the vastness of space, carrying with them the history of the universe. Invisible radiation ripples through the void, from the afterglow of the Big Bang to the high-energy particles known as cosmic rays. It's quite remarkable, really. This radiation, unseen by the naked eye, holds clues to the origins and the very fabric of the cosmos. Even the so-called vacuum itself is not empty, for quantum mechanics teaches us that the void seethes with fluctuations, particles appearing and vanishing in the blink of an eye. It's a bit mind-boggling, isn't it? The idea that emptiness is teeming with activity, a dance of particles that defies our everyday understanding. The very structure of the universe depends on what fills its spaces. Galaxies hold together because of dark matter, unseen but essential. The cosmos expands because of dark energy, a force woven into the fabric of reality. To speak of emptiness is to deny the presence of these profound mysteries. The truth is simple yet staggering. There is no empty space. When we say space is empty, What we really mean is that it is sparse, thinner than anything we know on Earth. Air surrounds us with unimaginable density compared to the delicate spread of atoms drifting between the stars. A cubic centimeter of air on Earth contains 10 quintillion molecules. That same volume in interstellar space may contain just one lonely atom. Compared to Earth, it feels like nothing. But when you spread those atoms across light years, you find clouds, nebulae, and rivers of matter stretching through the galaxy. Dust, too, is everywhere, though faint and small. These grains scatter light, dimming the stars behind them, painting the universe with delicate hues. They gather, clump, and form the seeds of planets. Without them, Earth could not exist. The dust of space is not dirt, not waste, but the ashes of ancient stars, ashes from which new stars will one day be born. Plasma flows silently through the galaxy, an unseen current, threading magnetic fields across unimaginable distances. It crackles with energy, shaping the behavior of stars, guiding particles through space. It's the most common state of matter in the universe, though, you know. It hides from our eyes. On Earth we see it only in lightning bolts and glowing neon signs, yet beyond our world it fills the heavens. And beyond even this lies the invisible majority, dark matter and dark energy. Dark matter holds galaxies together, making sure that stars don't drift apart. Dark energy pushes the universe outward, accelerating its expansion, stretching the fabric of space-time itself. We can't see them, can't touch them, yet they account for nearly all that exists. So where then is the emptiness? If you were to hand a child a box of crayons and ask them to draw the sun, chances are they would reach instinctively for the yellow stick. The sun has always been painted yellow in storybooks, cartoons, and art. From the earliest cave drawings to modern classroom posters, its round face is usually given a cheerful golden glow. This idea that our star shines yellow is one of the most persistent myths in human culture. It feels so natural, so obvious, that many never think to question it. After all, when you look up during the day, the sun seems to blaze with a golden light. At sunrise and sunset, it becomes a fiery red-orange disk. Surely then, in truth, the sun must be yellow. The sun, in its essence, is not yellow at all. The sun is, in fact, white. The sun emits light across a wide spectrum of wavelengths, from violet to red, with all the colors in between. When combined, these colors merge to produce what our eyes interpret as white light. You can see this for yourself whenever sunlight passes through a prism, splitting into a rainbow. That rainbow is the fingerprint of the sun, proof that it is not a yellow star, but a white one, radiating with nearly equal strength across the visible spectrum. Let us return to the phenomenon of Rayleigh scattering, the key to understanding why our eyes insist on seeing yellow. Imagine sunlight entering Earth's atmosphere at noon. The photons streaming in encounter molecules of nitrogen and oxygen. These molecules are just the right size to interact strongly with shorter wavelengths of light, especially violet and blue. When a blue photon collides with a molecule, it is bounced away in a random direction. This scattering is so effective that by the time sunlight reaches your eyes, much of the blue has been stripped out along the direct path. What remains is light that is slightly deficient in blue, and when you remove some blue from white light, the balance shifts toward yellow. This explains the paradox. The sun isn't yellow, but Earth's sky is. The sky borrows the blue for itself, scattering it into the dome above us, leaving the sun with a warmer hue when viewed from the ground. The yellowness is not a property of the sun, but of our planet's atmospheric shell. At sunset, this process is magnified. The sun's light has to travel through a much greater thickness of air as it arrives at a shallow angle. Blue and green wavelengths are scattered away completely, leaving behind only oranges and reds, and so, to us, the sun appears to change color. Yellow at noon, orange in the evening, red at dusk. Yet through it all, the sun itself is not altered in the slightest. It is our viewpoint that changes, our lens that distorts. Now, imagine leaving Earth behind for a moment. Picture yourself, aboard the International Space Station, orbiting about 400 kilometers above the planet's surface. From up there, the sun is stripped of all atmospheric interference. It shines not yellow, not orange, not red, but pure white. Astronauts describe it as almost blinding in its clarity. So white and so intense, it just defies comparison with anything on Earth. Against the black backdrop of space, the sun actually reveals its true nature. Its whiteness is startling, really, because we're so used to the filtered, yellow-tinged version we see down here. This unfiltered sun feels both alien and familiar, like meeting someone you thought you knew, only to discover a different face behind the mask. And well, it's no coincidence that the sun looks white from space. That's the physical truth. The sun emits nearly equal amounts of light across the visible spectrum from violet to red, and our eyes interpret that as white. Astronomers classify stars by color, which reflects their surface temperature. The hottest stars glow blue, with temperatures soaring above 25,000 Kelvin. Cooler stars glow red, some as low as 2,000 Kelvin. The sun, sitting at about 5,778 Kelvin, falls right in the middle, what they call a G-type main sequence star. But here's the subtlety. Even though the sun's spectrum peaks in the green part, it radiates broadly across all visible wavelengths. That wide distribution means no single color dominates, so our eyes just merge the entire range into a balanced white. So why not call it a green star? Well, green, unlike red or blue, isn't a natural color for stars when seen with the naked eye. If a star emits broadly enough to peak in the green, its total output includes enough red and blue light to mix into white. A green star, in practice, always looks white. That's why astronomers call the sun white, not yellow. But you might wonder, why did humanity hold so tightly to the idea of a yellow sun? The answer lies partly in perception, but also in symbolism. Yellow and gold have long represented vitality, power, and divinity. Gold was the eternal metal, resistant to tarnish, gleaming like a piece of the sun itself. To ancient eyes, honestly, the connection was just irresistible. In Egypt, the sun god Ra was imagined as golden, the source of life and kingship. Pharaohs wore golden crowns to reflect their connection to the solar deity. In Hinduism, Surya, the sun god, rode a chariot pulled by golden horses across the sky. In Greece, Helios steered a radiant chariot that bathed the earth in golden light. Gold and the sun became inseparable. Even in language, the association sticks with us. We talk about the golden hour, the golden dawn, or fields of gold. The imagery of a yellow sun isn't just science gone wrong, it's culture, meaning, and poetry. And yet the truth is, the sun isn't yellow at all. It's a cosmic reminder that our collective imagination can embrace beauty, even when it drifts a bit from reality. The myth of the yellow sun isn't trivial, It holds within it a lesson about perception and truth. We often take our senses at face value. If something looks yellow, well, we just assume it is yellow. But the sun teaches us otherwise. Our senses aren't perfect instruments, but interpreters, colored by context. From Earth, the atmosphere acts like a filter, shaping the sun's light before it ever reaches us. From space, that filter's removed and reality is revealed. The sun is white, and the fact that we see it differently isn't a flaw, but a feature of being earth-bound. This invites us to think more broadly, doesn't it, about how often our truths are shaped not by reality, but by perspective. What other things do we misinterpret because of the filters, cultural, emotional, environmental, through which we see them? The sun becomes a metaphor for the human condition. The truth may be white, but we perceive yellow. And yet, even if the sun is truly white, maybe the myth of the yellow sun isn't so wrong after all, at least symbolically, because when its light filters through our atmosphere, it paints the world with a palette of extraordinary beauty. The golden hour of dusk bathes landscapes in warmth. The reds and oranges of sunset inspire poetry and awe. The mid-morning glow awakens fields and seas with gentle warmth. All of these colors exist because of the scattering that tricks us into thinking the sun is yellow. In this sense, the yellow sun is both myth and truth, false in physics, true in experience. The golden sun is a product of our unique planetary home, a reminder that Earth shapes not only our survival but our perception of the cosmos. So, is the sun yellow? No, it's white, a star shining with balanced light across the visible spectrum. But on Earth, seen through our veil of air, it takes on the hues of gold, orange, and red. It appears yellow to us, and in appearing yellow, it became golden in myth, golden in religion, golden in art. The truth isn't meant to erase the poetry. Instead, it enriches it. The sun is white, but it gives us yellow. The sun is balanced, but it offers us beauty through distortion, and perhaps that's what makes it so wondrous. That a star can be pure in itself, yet still paint the skies with the colors of our dreams. The sun rises in the east and sets in the west. It's one of the first truths we are taught as children. The sun, we are told, rises in the east every morning, journeys across the sky, and sinks into the west each evening. It feels so simple, so obvious, that to question it would seem, well, a bit absurd. Yet like so many of humanity's early truths, this too is only half real. A story shaped by perception rather than by the deeper mechanics of the cosmos. Let us begin at the beginning, with what we see. Each dawn, a glow begins low on the horizon. Slowly, the edge of the sun peaks above the Earth's curve. The air fills with color. Shadows stretch long and thin as day is born. The sun climbs higher, warming the land, marking time. Eventually, in the evening, it drifts downward and slips beneath the opposite horizon, surrendering the sky to night. This daily rhythm is so consistent, so utterly dependable, that ancient civilizations based their calendars, their myths, even their survival upon it. Farmers rose with the sun to till their fields. Sailors steered their ships by the knowledge that the sun set westward. Priests built temples aligned to the dawn of the solstice. To them, the sun was a cosmic traveler, faithfully crossing the heavens in a predictable path. But of course, the truth is more complicated. The illusion of rising and setting. The sun does not rise, the sun does not set, it is the earth that turns. We live on a sphere, spinning steadily in space, rotating once every 24 hours. As it turns, different parts of its surface are brought into sunlight or cast into shadow. To an observer standing still upon the ground, this rotation creates the illusion that the sun itself is moving, appearing, climbing, and then disappearing. In reality, the sun remains essentially fixed, at least relative to our short daily scales. It is our spinning planet that delivers us to the light each morning and carries us back into darkness each night. The sun's journey is an illusion, a dance choreographed not by the star but by our own motion around it. So why do we insist that the sun rises in the east and sets in the west? Well, it's because of the direction of Earth's rotation. The planet spins from west to east. From our perspective on the surface, this makes the sun appear to rise on the eastern horizon, travel across the sky, and set in the west. But this east-west story isn't universal. It's really bound to Earth, to its particular orientation, to its tilt and rotation. On other planets, the story changes quite a bit. On Venus, The planet spins in the opposite direction to Earth. If you could stand upon its thick, cloud-shrouded surface, the sun would seem to rise in the west and set in the east. On Uranus, tilted on its side like a rolling ball, the sun's path would be strange and disorienting, circling near the horizon for long stretches of time. And on Mercury, with its slow rotation and close orbit, a day is actually longer than a year. From some locations, the sun would appear to rise, pause, reverse course, and then continue again. A surreal ballet of motion, really. So, the idea of a sun that rises in the east and sets in the west isn't a cosmic law at all. It's an earth-bound truth, shaped entirely by the way our planet spins. Before folks really grasped the science of rotation, different cultures, tried to explain the sun's apparent journey across the heavens. In ancient Egypt, the sun god Ra was imagined as sailing across the sky each day in a golden boat. At night, he descended into the underworld, traveling through darkness before being reborn in the east at dawn. In Greek mythology, the god Helios drove his chariot across the sky, pulled by fiery steeds. Each evening he descended into the west, only to begin again the next day. The Navajo told stories of the sun carried across the sky by a divine bearer. In Japan, the goddess Amaterasu emerged from a cave each morning, bringing light to the world. Across cultures, East was associated with beginnings, with birth, with hope, while West became the realm of endings, of rest, of death. These associations still echo in language and ritual today. But hidden behind the stories was always the same mystery. Why did the sun move so reliably from east to west? The true answer, that Earth itself spins, would not be fully grasped until thousands of years later. It was the Polish astronomer Nicolaus Copernicus in the 16th century who crystallized the idea that Earth itself is not still but moving. He proposed the heliocentric model, in which the Earth rotates daily on its axis and orbits annually around the sun. This was a radical shift. For millennia, people had believed Earth was fixed and unmoving, with the heavens revolving around it. To say otherwise was not only scientifically daring, but spiritually dangerous. And yet, the evidence grew. Observations of the stars, the planets, and the seasons began to align perfectly with the model of a spinning, orbiting Earth. By the time Galileo turned his telescope to the skies and Johannes Kepler described the laws of planetary motion, the myth of the sun's rising and setting as its own motion had been overturned. The sun was no traveler at all. We were the ones moving. But even with the science revealed, the poetry of the myth remains. The sun still rises for us, and we still chase its setting glow. Language preserves the illusion, because it reflects our lived experience. Perhaps that is the deeper truth, that myth and science are not enemies but companions. Science gives us the explanation, the mechanics, the cosmic stage. Myth gives us the meaning, the emotional connection, the story that ties our lives to the heavens. And so, the sun does not rise in the east or set in the west. The earth turns, and in turning it brings us to light and then to shadow. But to say the sun rises is not entirely wrong. It rises in our perception, it rises in our rituals, it rises in our hearts. Black holes occupy a special place in the imagination. To many, they are cosmic vacuum cleaners, lurking silently in the void, ready to swallow stars, planets, or even entire civilizations. Popular culture reinforces this idea. Movies, television shows, and books depict black holes as insatiable monsters, devouring everything that strays too close. The language itself, event horizon, singularity, gravity well, conjures images of unstoppable hunger. But as with so many cosmic myths, the reality is both stranger and more nuanced than fiction suggests. Black holes do not roam the universe seeking victims. They do not suck in everything around them like a giant celestial straw. They are far more subtle, bound by the same laws of physics that govern stars, planets, and galaxies. A black hole forms when a massive star collapses under its own gravity at the end of its life. Its core implodes, compressing mass into a point of nearly infinite density, the singularity. Around this point lies the event horizon, the boundary beyond which nothing, not even light, can escape. The event horizon is not a cosmic vacuum hose, it is a threshold. Objects can orbit a black hole safely, just as planets orbit stars. The Earth orbits the Sun without fear of being sucked in because gravity is not about consumption, it is about attraction. The Sun does not pull Earth toward itself like a vacuum. It provides the centripetal force that keeps our planet in orbit. Similarly, a black hole's gravity is strong, but it acts according to distance. If our Sun were suddenly replaced by a black hole of equal mass, Earth would continue orbiting it as before, oblivious to the change. The danger comes only when an object crosses the event horizon, the point of no return, not simply from being nearby. Black holes are often surrounded by accretion disks, rings of gas, dust, and stellar debris spiraling toward the event horizon. These disks glow brightly due to friction, heating the material to millions of degrees. It is this luminous display, not some invisible suction, that gives black holes their fearsome reputation. Objects caught in an accretion disk are not pulled in from afar like iron filings to a magnet. They fall only because they venture too close, losing energy through interactions with surrounding matter. Black holes are selective in what they consume, and space is vast enough that most stars and planets never approach one. The metaphor of a cosmic vacuum cleaner is therefore misleading. Black holes are not indiscriminate devourers. They are regions of concentrated gravity, affecting nearby space in precise, predictable ways. Despite their reputation, black holes are surprisingly common. There are stellar mass black holes formed from individual stars scattered throughout galaxies. There are also supermassive black holes, millions or billions of times more massive than the Sun, residing at the centers of galaxies. These supermassive giants anchor the motions of stars in their galaxies, but even then, their gravitational influence extends no farther than their mass allows. Stars orbit them, galaxies swirl around them, and yet the vast majority of matter in the universe never crosses the event horizon. Black holes are not universe-eating monsters. They are sculptors of structure, shaping the formation of galaxies and regulating cosmic evolution. The myth of black holes as indiscriminate destroyers is reinforced by dramatic imagery. Science fiction often depicts spaceships helplessly drawn in, twisting and stretching until they vanish. While the spaghettification effect, that's the extreme stretching due to tidal forces near a singularity, is real, it only occurs extremely close to the event horizon. Vast distances are safe. In fact, a spaceship could orbit a black hole safely for decades, experiencing the same orbital dynamics as any planet around a star. Even the idea of black holes sucking in light is misunderstood. Light does not move differently until it approaches the event horizon. Black holes bend space-time, curving light's path, but they do not actively reach out to pull photons from across the universe. One reason black holes have such a fearsome reputation is that they cannot be seen directly. Light cannot escape their event horizons, so we rely on indirect evidence, X-rays from accretion disks, the motion of nearby stars, or gravitational waves produced when two black holes merge. These observations reveal the invisible hand of gravity, but they do not reveal a devouring monster. Black holes are invisible not because they are hungry, but because of the fundamental physics of space-time and light. In truth, black holes are among the most fascinating objects in the universe precisely because of their subtlety. They challenge our understanding of physics, warping space-time and testing the limits of relativity and quantum mechanics. They are laboratories for extreme conditions, not vacuum cleaners roaming the cosmos. The myth of the black hole that sucks everything in is compelling because it speaks to human fear, the fear of being powerless, of encountering the unknown. But the universe is not cruel. Black holes are not predators. They are natural consequences of gravity acting on massive stars. They remind us of the limits of our intuition and the beauty of a cosmos far stranger than any fiction. This is one of the most persistent myths of human physiology, psychology, and culture, that we only tap into a tiny fraction of our brain's potential, leaving 90% dormant, waiting for the right stimulus to awaken it. It's a myth that has inspired books, movies, self-help programs, and countless motivational speeches. Images of people unlocking hidden genius, unleashing superhuman memory, or developing telekinetic powers all stem from this simple, seductive claim. Yet, like the other myths we have explored, the truth is far more complex, far more wondrous, and far less literal than the myth suggests. The precise origin of the 10% claim is murky. Some attribute it to early neuroscientists of the late 19th and early 20th centuries, who observed that only a fraction of the brain seemed actively involved in certain experiments. Misinterpretations and exaggerations of these findings likely evolved over time. Psychologists like William James referred to humans accessing only a small portion of their mental resources, but never meant it literally. Despite the shaky foundation, the idea caught hold. It was simple, memorable, and enticing. Humans love the notion of untapped potential, of latent powers lying dormant inside themselves. It appealed to the dreamer in every student, the visionary in every artist, the seeker in every explorer. The human brain has long been shrouded in mystery. For centuries, people have marveled at its complexity, puzzled by its quirks, and speculated about its hidden potential. This fascination naturally gave rise to myths, the most famous of which claims that we only use 10% of our brain. The rest, according to popular imagination, lies dormant, a vast reservoir of untapped genius waiting for the right spark to awaken it. It's a tantalizing idea, isn't it? To think that we are walking around each day with 90% of our cerebral power untouched inspires dreams of mental feats beyond comprehension, photographic memory, telepathy, instantaneous learning, and perhaps even the unlocking of psychic abilities. It's a concept that shaped popular culture, motivating novels, movies, and self-help programs alike. Yet, as alluring as it is, the 10% brain myth is a profound misunderstanding of neuroscience. Tracing the roots of this myth reveals how easily small misunderstandings can grow into pervasive cultural beliefs. In the late 19th and early 20th centuries, neuroscientists were still mapping the brain's function. They discovered that only portions of the brain appeared to activate during specific tasks. Some neurons, some regions, seemed quiet during observation, leading to the mistaken idea that much of the brain was unused. Psychologists like William James hinted at the untapped potential of the mind, suggesting that humans only harness a fraction of their mental resources. James's words were metaphorical, describing unused capabilities in thought, creativity, and focus, not literal dormant tissue. Over time, however, the metaphor was misinterpreted, transformed into the literal claim that 90% of the brain lies unused. The media amplified the idea. Early motivational writers and self-help gurus embraced it because it promised limitless human potential. Films and literature dramatized the concept. Characters suddenly unlock hidden powers, mastering skills instantly or perceiving the world in extraordinary ways. Once entrenched, the myth became so familiar that many accepted it as fact. Modern neuroscience, powered by tools such as functional magnetic resonance imaging and positron emission tomography scans, paints a dramatically different picture. The truth is this: Virtually every part of the brain has a known function. Even simple, seemingly automatic actions require complex coordination across multiple brain regions. Consider walking. A seemingly mundane act involves the cerebellum to control balance, the motor cortex to direct movement, the basal ganglia for habit formation, and sensory areas to process environmental input. Every step activates a network, a symphony of neurons firing in precise orchestrated patterns. Thinking, memory, creativity, emotion, all involve distributed networks. The idea of dormant tissue is incompatible with these observations. The brain is never truly off. Even during sleep, when our consciousness rests, the brain engages in essential processes, consolidating memories, regulating emotions, and clearing metabolic waste through the glymphatic system. Even the areas we might perceive as quiet are not unused. They are involved in regulation, integration, and preparation for future tasks. The brain is not a machine with idle components. It is a living, adaptive organ, constantly active, constantly reorganizing itself in response to stimuli. Although the 10% myth is false, it captures a deeper truth. The human brain is plastic, capable of extraordinary growth, adaptation, and learning. This quality, known as neuroplasticity, allows the brain to rewire itself in response to experience. Learning a new language, mastering a musical instrument, or developing expertise in a skill physically alters the brain. Neural pathways strengthen, synapses form new connections, and unused circuits are repurposed. In this way, humans can unlock potential, not because parts of the brain are dormant, but because the efficiency and connectivity of neural networks improve. This principle underlies much of education, rehabilitation, and cognitive enhancement. Stroke victims, for example, can retrain parts of their brain to compensate for damaged regions, regaining lost functions. Children exposed to rich sensory environments develop stronger neural connections. Focused mental practice can lead to exceptional skill mastery, demonstrating that untapped potential is not a matter of hidden tissue, but of cultivated capacity. Why does the myth persist, despite overwhelming evidence to the contrary? Partly, it is aspirational. It promises that our ordinary self is merely a shadow of what we could become. It appeals to our desire to transcend limitations, to imagine a self capable of extraordinary feats. Movies like Lucy and Limitless dramatize this fantasy, showing characters who, by unlocking unused portions of their brains, achieve superhuman intelligence and perception. Self-help industries exploit it, marketing supplements, courses, and exercises that claim to awaken hidden potential. The myth is seductive because it is simple, memorable, and empowering. It suggests that we are inherently incomplete, but capable of dramatic transformation. Yet the real brain, fully utilized and endlessly adaptive, is just as remarkable, if not more so, than the fantasy of untapped tissue. Every neuron, every synapse, every pattern of firing contributes to consciousness, perception, memory, and emotion. The brain is a universe unto itself, intricate, interconnected, and dynamic. From the hippocampus storing memories to the prefrontal cortex regulating complex decision-making, every part serves a purpose. The myth may make us feel that we are limited, that genius lies hidden. The truth is that genius already exists in the brain, in its capacity to adapt, imagine, and create. Learning, focus, and deliberate practice are what unlock this potential, not dormant tissue. Even ordinary thought is astonishing. To see, process, remember, and act is an act of complexity beyond the scale of human intuition. The brain does far more than we consciously recognize, orchestrating perception, motor control, emotion, and cognition seamlessly, moment by moment. The 10% myth endures not because it is accurate, but because it reflects a deep human longing, the desire to transcend, to grow, to be more than we are. In this sense, it is metaphorically true. Our potential is vast, our capacity for learning immense, our minds capable of far more than we routinely exercise. But the metaphor need not distort the fact. The brain is already a marvel. It is fully active, fully engaged, and fully alive. Every thought, every feeling, every movement is a product of this magnificent organ, a testament to the complexity of life itself. To imagine that 90% of it lies dormant is to underestimate reality. The brain is not a partially used tool waiting for awakening. It is a dynamic, vibrant cosmos of activity, every part contributing to the miracle of consciousness. The myth of the 10% brain reminds us that humans are drawn to simplification, to stories that make the incomprehensible manageable. Yet it also reminds us of a deeper truth, that we are capable of growth, change, and creativity beyond what we often imagine. Science and myth in this case are not enemies. The myth inspires, the science clarifies. Together they reveal the wonder of human potential, not hidden, not dormant, but alive, intricate, and waiting to be cultivated. Our brains, like the universe itself, are far more than they appear at first glance. They are active, dynamic, and endlessly remarkable. A universe within us, as vast and mysterious as the stars above. Throughout this journey, we have explored 5 of the most enduring myths about space, the sun, black holes, and even our own minds. Each of these myths has persisted not because they are true, but because they capture something profound about human perception, imagination, and curiosity. We began with the sun, the star that gives life to our world, and discovered that it is not yellow, but white, a dazzling furnace of light, whose apparent color is shaped by the air we breathe and the lens through which we see. In that simple truth lies a lesson. Reality often differs from perception, and the beauty we see is filtered through the delicate veil of our senses. Next, we considered the apparent motion of the sun, rising in the east and setting in the west. Yet the sun does not travel across the sky. Earth spins, carrying us into light and shadow. This myth reminds us that the cosmos is far stranger than it appears, that the universe operates on scales and motions that often defy instinct, yet still provide order, rhythm, and meaning to our daily lives. We then confronted the idea of black holes as ravenous monsters sucking in everything in their path. In truth, they are not hunters, but sculptors of the cosmos, regions of concentrated gravity that follow the same laws governing stars and planets. They remind us that danger is relative, that the universe is governed by principles far more subtle and elegant than any fiction could convey. Finally, we turned inward, confronting the myth that we use only 10% of our brains. Here, the lesson is both humbling and exhilarating. The brain is not a half-empty vessel, but a dynamic, fully active network, capable of extraordinary adaptation, learning, and creativity. Potential is not hidden in dormant tissue. It exists in the connections, the practice, the focus, and the curiosity that we nurture every day. Across these myths, a pattern emerges. Human beings are storytellers by nature. We seek simplicity, narratives that explain the mysterious, images that give form to the vastness of the universe. Myths are not failures of reason. They are expressions of wonder, attempts to grasp the incomprehensible. Science, in turn, does not strip away that wonder. It deepens it, revealing truths that are often stranger, richer, and more beautiful than the myths they replace. The universe is not yellow, it does not rise or set, it does not indiscriminately devour, and our brains are not dormant. Yet in exploring these truths, we gain a sense of awe. We see the sun not as a golden disk, but as a white star fueling life. We understand that black holes are elegant warps of space-time, not monsters. We recognize the brain's brilliance, fully awake and endlessly capable. And perhaps the greatest lesson of all is this: the cosmos, like the mind, is more intricate than first appearances suggest. To perceive it accurately requires curiosity, observation, and humility. Myths guide our imagination, science refines it, and together they illuminate the boundless beauty of existence. So when you look at the sky tonight, or ponder the limits of human potential, remember that reality is often more wondrous than myth. Question what you see, explore what you do not, and take joy in the fact that both the universe outside and the universe within are richer, stranger, and infinitely more magnificent than you could ever imagine.